So now let's come to the third section of this chapter, logic. So this section summarizes the fundamental concepts of logical representation and reasoning. So first, what is the concept of logics? So logics are formal languages for representing information such that conclusions can be drawn. So we say that logic base of agent consists of sentences. So these sentences should be expressed according to the syntax of the representation language. This is the syntax. So the syntax defines the sentences in the language. Okay. And then a logic must also define the semantics. That is the truth of each sentence. So semantics defines the meaning of the sentences. Actually, the truth of sentence in the word, the truth. Here I present some examples. The first one is x plus 2 is greater than or equal to y. So this is a sentence. You can understand this without any problem, okay? And this x2 plus y is greater than the brackets. Do you know what it means? So this is not a sentence because it don't obey the rule of how to construct a sentence. This is called the syntax. Okay. So we need to obey the syntax to organize the sentence. If don't, there's no meaning. And then we come to understand what is the semantics of a sentence. So the summation of x and 2 is greater than y or equal to y is true in a word where x is 7, y is 1. It means if x is assigned a value 7, now 7 plus 2 is 9. 9 is of course greater than 1. So this inequality holds based on this assignments. So this assignment called a word. So under this assignment, this is true. The semantic is true. The truth value is true. Okay. And if x is assigned as 0 and y is assigned as 6, now we know the summation of 0 and 2 is less than 6. So it is false on this assignment. So this is the semantic of this sentence. Okay. So these two sentences mean every sentence should be either true or false, corresponding to the semantics. So now that we have known the notion of truth, we are ready to talk about logical reasoning. This involves the relation of logical entailment between sentences. That is, a sentence logically follows another sentence denoted by this notation called entailment. So entailment means that one thing follows from another. Here alpha follows from KB. Okay, so knowledge base KB entails the sentence alpha if and only if alpha is true in all words when KB is true. Now, for example, if the knowledge base contains two sentences, the genes 1 and the rates 1, so it of course entails the genes 1. Okay, and the other example is x plus y is 4. The summation of x and y is 4 entails 4 equals to x plus y. So this of course holds due to the commutative law. Okay. So in this slide, we introduce an important concept called model. So logicians typically think in terms of models, which are formally structured words with respect to which truths can be evaluated. So it is somewhat uneasy to understand. So let's give more concrete explanation here. So we say M is a model of a sentence alpha if alpha is true in M. So we use the notation M alpha to mean the set of all models of alpha. M alpha is the set of all models of alpha. Okay. So based on the definition of model, we know that KB entails alpha if and only if the model of KB is a subset of the model of alpha. Because the model of KB is a set. Okay, the model of alpha is also a set, but this set is a subset of this one. Okay, so as shown in this figure, here KB, the model of KB is shown in this shaded one. Okay, and the models of alpha is the larger one. So we know, of course, MKB is a subset of M alpha. Then we can conclude KB entails alpha. Okay. Which can be said as this: the models of KB rules out more possible words in this circle. Okay, so if KB entails alpha, all solutions to KB are all solutions to alpha. All solutions to KB are solutions to alpha. The MKB is a subset of M alpha. It is equivalent to KB entails alpha. So I hope every one of you should understand this, because entailment we will use to perform the logical inference. Okay.